Zoki dokie. Today we're going to be talking about theoretical probability and its complement. We spoke a little bit about it last week when we were doing the M&M activity, but theoretical probability is based on reasoning. And it'll be written as a fraction or ratio. Reasoning is basically thinking. You just got to think about it. It's basically the event has not occurred as of yet, but if you are thinking of the event, you're thinking of all the total possibilities and the possibilities that are favorable to you. So when we're writing it as a fraction, the numerator, the number on top, is the number of favorable outcomes, the things that you want to happen. Your denominator is the number of total outcomes, all the different things that could happen. The ones that you want go on top, all the things that could happen go on the bottom in your denominator. In science, theoretical is known as making a hypothesis. It's our educated mathematical guess, and that's very much what we're talking about when we're saying that it's based off of reasoning. It's almost like an educated guess, a hypothesis. If I were to spin this spinner, what is the theoretical probability that I will land on an odd number if all the spaces on the spinner are the exact same size? So I'm going to go around and I'm going to identify all the odd numbers. I know odd numbers end in a 1, 3, 5, 7, or 9. And then so I know 5 is my favorable. That's my numerator. Total, there are 10 total. The biggest number on there is 10. However, at this point, I need to go through and I need to simplify that fraction if I can. I notice that I can divide both the numerator and the denominator by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So the theoretical probability of landing on an odd number is 1/2. Or for every 2 total spins, theoretically, I will get an odd number 1 time if we spin it twice. Every 2 spins, I should get an odd number. The next one says, what is the theoretical probability that I will not land on an odd number? So this is very important, that not word right there. If it's not odd, it's even. There are 10 numbers, 1 through 10, which means half are odd, half of them are even. So if we want not odd, there are 10 total numbers, 5 of them are not odd, 5 of them are even. Again, we can simplify, divide the numerator and the denominator by the exact same number. 5 divided by 5 is 1, 10 divided by 5 is 2. So the probability, the theoretical probability of getting not an odd number is also 1 out of 2. I'm going to skip that, and we're going to come right down to the next part. So, if we go down, we see a blank of an event is all the other outcomes. So this is a complement. A complement of an event is all the other outcomes, the ones that are not favorable. Okay, and together the event, favorable, and its complement make all possible outcomes. All of this should add up to one whole. The favorable plus the complement, the not favorable, should add up to 1 whole. So if we come back up to this particular example, all of the odd is 1/2. The ones that are not odd is 1/2. 1/2 plus 1/2 is equal to 1. 1 whole. All right. So the next problem reads, a student has a set of cards. Each card has a picture of one shape. The table shows the number of cards that have a picture of each shape. The student will randomly select one card from the set. Which statement is true? So first things first, we need to figure out the total number of cards. We've got 8 plus 12 is 20, plus 10 is 30, and I know 6 plus 4 is also 10, so 30 plus 10 is equal to 40, so there are 40 total cards. And let's see, let's go back and reread to see. Each card has a picture of one shape. The table shows the number of cards that have a picture of each shape. The student will randomly select one card. So we're looking for a true statement. The probability of selecting a card with a picture of a circle. And all of our answer choices are talking about pictures of a circle. So we need to figure out the theoretical probability of choosing a card with a circle. So I know my denominator is 40, and there are 8 total circle cards. However, again, we need to go ahead and we need to simplify. If you can't think of the biggest common factor, I know that both 8 and 40 are even, so we could divide by 2, and we get 4/20. Again, 4 and 20 are even, so we could again divide both the numerator and the denominator by 2. Again, even, divide both by 2, and we get 1/5. We could have, if you had noticed that 8 is divisible by 8, 40 is also divisible by 8. If you had divided them by 8, we would have gotten 1/5 as well. So the probability of selecting a card with a picture of a circle is 5/8. That is not true. We know it to be 1/5. Is 3/8. That is also not true. So A and B are out. So the probability of selecting a card with a picture of a circle is 1/5, and the probability of selecting a card that is not a picture of a circle is 4/5. If we add 1/5 plus 4/5, we get 1 whole. That is also true. C is most likely our answer. We're going to check D though. The probability of selecting a card with a picture of a circle is 4/5. That's not true. D's out. So our only possible answer is C. Oh, good. It got chopped up. All right. Last question. A teacher has a container of paper clips. She will randomly select one paper clip from the container, and it says the container has 8 pink paper clips, 14 purple, 12 yellow, 16 blue. Which statement is true? The probability of selecting a purple paper clip, so we definitely want to know the theoretical probability of selecting purple, and B is up top, so I'm gonna just like get that out of there. We want purple. So we need to figure out the total number of paper clips first. Let's see, 8 plus 12 is 20. 14 plus 16 is 30. 20 plus 30 is 50. So the total number of paper clips is 50. Now we want to come up with a fraction of the probability of selecting purple. There are 14 purple, so 14 is our favorable. It goes on top. We need to simplify because 14 and 50 are both even, so they're both divisible by 2. 14 divided by 2 is 7. 50 divided by 2 is 25. 7 is prime, which means its factors, the factors of 7 is only 1 and 7, are only 1 and 7. 25 is not divisible by 7, so this is its most simplest form. So the probability of selecting purple paperclip is 3/4. That is not true. It's 7/25. The probability of selecting purple is 1/4. That's not true. The probability of selecting purple is 18. That is also not true. The probability of selecting purple is 7/25. 7/25 and 7/20, and the probability of selecting a paperclip that is not purple, its complement, is 18/25. 7 plus 18 is 25. 25/25 is 1 whole. So that is also true. C's out, B's out, A's out. And that is theoretical probability. You've got an assignment on Canvas to work on. Oh, bye, 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 bye.